Hi everyone, let's solve this trapping rainwater from Leetcode of 42 today. This is labeled as hard question. It says that given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So assume that you are given some heights in an array named height, and then there are like different kinds of height, right? Let's imagine that height is walls, different kind of walls, zigzag walls, right? And then when it rains, certain water can be trapped in those zigzag short and long height of the wall, right? So we have to basically find the answer of how much water can we trap on those heights. So basically that's the idea. So I have taken an example from Leetcode, which is this one, the second example of height, which is 420325, which is right here. And then we're trying to see how this is going to be easier by representing this in this graph, right? So this is 4, height of 4, this is 2, this is 0, it doesn't have any height, this is 3, 2 and 5. Now if you can see it here, when it rains, certain water can be trapped in these kind of empty areas. Now if it rains here at the end, at the first and in the end, if you see it here, if it rains ever, then there's nothing to trap the water, so water will spoil out of the bound from that position. And if you see it here too, it's also going to leave this wall. The water cannot go inside, it will go out. So basically you can say that these rightmost and leftmost values won't have that much of participation when we are calculating our trapping rainwater. I mean, basically we will not calculate the water, how much water can those accumulate in our final answer. But if you see it here at 2, I want you all to think about it in a brute force way initially, like a brute force way. Don't think about how can you optimize initially. Think about how can you come up to a solution that is brute force. And then after you analyze the brute force approach, you can go to the optimal approach. Right? So initially don't think about any optimal approach. Just basically I want you all to think about one basic thing. If you are at index 0, try to calculate the rainwater, how much you can trap on that specific index. Go to 2, also try how much rain can you trap on that section, like that, brute force way. So if you look at here, since 4 and 5, these are the right and leftmost heights, and we cannot use that because if rain falls here, the rain will go outside, right? It won't be trapped inside. So but if you see it here at index 0, which is 2, it is containing some of the water, right? How much water it's containing basically? Well, basically you can say that it's containing water 2, right? 2 height of water it is containing. Now if you see it here 0, how much water it's containing? Well, it's basically containing the whole section of the given empty area, which is 4. Now how can I easily calculate it? How can it easily be calculated by just looking at the map? Well, it's pretty simple. When you are at certain index, let's say you are at this index, which is 2, right? If you want to calculate the water trapped in this specific area, you would look on your left side and then right side, left side and then the right side. Then you would say, what is the leftmost value? What is the leftmost wall? And in your right side, you would say, what is the rightmost wall? Right? At certain index, I want you all to imagine like this. At certain index, ask yourself, what is the leftmost wall that I have? And then what is the rightmost wall that I have? Now, after figuring out that, use simple analogy. Here, my leftmost wall is 4, right? At this index, which is 2. And my rightmost wall is 5. The height of that is left side is 4, right side is 5. Now when it rains, which height do you think it's controlling the water? Well, it's pretty obvious that whichever height has a small value, this 4, right? This 4 is controlling the water that can be trapped in this. I haven't said that water can be trapped from here, because that doesn't make sense. It will overflow, right? But the smaller height on the left side is controlling the water of how much it can go. That's why I can easily say that the height is 4 here, or the water can be trapped of 4. Now, if you see it here, this, if you go to another index which is 3, you have a gap of 1 here, right? You have a gap of 1. How? Since this is 4, this is 5, and this doesn't control our the water can be, how much water can be trapped. Now it's only left with 1. Since this whole thing is a wall and it also doesn't contain a water, it doesn't trap water, so water can be trapped only here. That is basically you are reducing your value 3 from 4, which is going to be 1, so you add that 1 here. Now if you go here at index 0, 1, 2, 3, 4, which is a value 2 of height, you also say that what is the leftmost value and what is the rightmost value. Here 4, here 5, right? And you would say, if 4 is controlling my height, I am already 2. I have already contained the height of 2. Well, I am simply going to subtract myself from my leftmost value, and then that amount is going to contain the water. That is basically containing the water. So that's how you think about it. Now, I know this histogram or the graph looks so messy, but I'm pretty sure that after this video, you'll understand this question, and then you'll never forget this trapping rainwater, which is a hard question. Now, if you see it here, what were you doing? At each index, you were simply calculating your left max and then the right max, right? When I said that here at 0, calculate your leftmost and then the rightmost, I was basically saying that calculate your leftmost value and then the rightmost value, and then that particular index's value's answer will basically going to be minimum of left max or right max. Why are we using minimum here? Well, the reason we are using minimum here is simply, just see this example. Okay, let's say this was your the trapping rainwater problem. Let's say this was 4, let's say this was 2, let's say this was 3. Now let's say you are at index this one, and let's say if it starts raining, right? If it starts raining, the water, if it starts raining here, water will flow outside and then it will go inside too. If it starts raining here, the water will go outside. So these two endpoints are not controlling how much water can we put. But if you find the maximum of 2 on the left side, which is 4, and then maximum of 2, which is 3 on right side, which is 4 and 3, right? Now label it here, just label it here. Water won't go here because this section is a wall, and then water will overflow outside. If you do it here, it doesn't make sense. This is not controlling the water. So this small area, this small height is controlling the water. So that's why you are taking minimum there, right there. After that, after you take the minimum of both extreme points on left and right, you have to decrease the value's height. Why? If you don't do, you would simply mismatch the value like this here. The left is 4, right is 3, right? Now you have value of 3. Is 3 your height? No, because this is already controlling 2, right? If this is already controlling 2, now it only has space of 1. So you have to decrease yourself. You have to eliminate yourself from here, which is basically height of I, and then it will give you 1. So this particular value 2 can only trap water of 1 height. I hope this makes sense. I'm gonna show you the code here, which is a brute force approach. Initialize your answer to be 0, and then start your index from 1, and then go till height of size minus 2. The reason I want you to go to height of size minus 2 is because simply see this. What is our example? 420325, right? I'm gonna write that here. 420325. So if you do height dot size, it will give you a size of 6. If you decrease -1, it will point here, right? But if you decrease -2, it will point here. And then pointing here makes sense because this is not controlling your height, and this is also not controlling your height initially, right? Those are the end points. So you restart your loop here to go there. Now assign your left max to be area of I, which is basically 2. Assume that this is your leftmost value for this 2 itself. Now is that the correct answer? No, 2 is not the left max value for 2. So you start your loop from I minus 1, which is basically 0. Now you are pointing here, and then you are checking if my left max, which is basically 2, is actually maximum than the height of 4. Then you will find 4 as your max height and then assign it here, and do the same for the rightmost value. Calculate the rightmost value, which is 5 for 2, and then you would basically have 5 here, and then in answer you would calculate the minimum of both, because minimum height is controlling the water, how much it can go inside those area or walls, which was basically 4, and then reduce the height of I, which is basically 2 in here, 2, right? That will give you answer is 2, and then store that in answer and repeatedly calculate for each index. So you had 2 here. The reason you had 2 is here is simply so 4 is this long, 5 is this long. 4 was controlling the water, so but it already contained 2, so that's why it's only controlling 2. So this is how you solve the question of trapping rainwater using a brute force approach, using 2 loops. The reason that this approach is not good is because it's using your big O of n square time complexity. The time complexity of this question is going to be big O of n square, which is a quadratic time complexity. And now we can optimize this question. So I'm gonna show you how can we optimize this question using big O of n time complexity. Now in order to optimize this question, we will be using 2 different spaces for each of the left max and then the right max value. What I'm trying to say is basically we were using big O of n square time complexity in our previous question by repeatedly calculating left maximum and then the right maximum for each of the value, as you can see it here in this example, right? But we can optimize this question in big O of n time complexity. Big O of n time complexity, I'll show you how. So first you want to create a left max array which will be storing all of the left maximum points for a given index, and then you'll also create a right max array which will store all of the right max elements, all of the right extreme points for the given value, right? So for our this one 420325, I'm gonna do it like this, and then you'll just use one loop for each of these 2 array. For each you'll basically use 2 loops but differently. You use your first loop in order to calculate the left maximum for each of the value. You'll initially assign your left max with 4 because 4 is your value at the end point and it won't count in a trapping rainwater problem. And then after that you go to the another index and compare that with the previous left maximum, which is basically 4, right? And then which is the previous left maximum, which is 4. Basically you'll store 4 again here. Now you'll again go to this index and then compare your value 0 with previous left maximum, which is 4. Again it is 4, then you'll store 4 here, and then you'll do same thing for these 3. Height of 3 is still less than the previous maximum height, so still you will store 4. Now you'll still go here and then go to 2, and then you'll calculate the maximum for 2, which is still going to be 4, which is 4. Now you won't be calculating any left extreme points for these 5 because this is also the last value, and then it doesn't count in our trapping rainwater problem, right? And then now you will use another loop. You used your first loop, which was basically single loop, and then you want to use another single loop to calculate the right max. Now in the right max, which is basically the extreme point in our right side, basically it's going to be the maximum value that we have in our right side, which is 5, right? That's our end point because we won't be using that in our trapping rainwater problem. So we fix that value, which is 5 in this current scenario, and store it in the end of an array. Now we will use a backward loop to compare, starting with this one. We'll basically compare what is my left maximum endpoint, which is 5, right? You will compare that with 5, and whichever is maximum, that will store here, which is going to be 5. Since 2's maximum endpoint is 5, so you'll basically do it here. Now you go to this index and ask yourself, what is the right max value for 3? Still it's 5, then store 5. What is the right max value for 0? It's still 5, store 5. What is the right max value for 2? Which is also 5, right? So that's how you store the maximum value for left and then the right point. Now after successfully using 2 different loops for calculating left max point and then the right max point for each of the index, you will basically use a single for loop to calculate the minimum of these each value and then decrease the height given. So if we start from here, the minimum is 4, and then since the minimum of 4,5 will come as 4, and then you'll basically decrease your height of 2, which is going to be 2. Same goes for here, which is 4,5. This will give you 4, and then you will reduce yourself, which is 0. It's gonna be 4, so you add 2 and 4, and then again go here 4,5. The minimum is 4, and then you decrease yourself, which is height of 3. Then it will give you 1. The current answer is 1 plus 4 plus 2. It's 7. And then you'd go here at 2, basically here, and then see that particular value, which is 4, and then calculate or decrease your value 2, and it's gonna give you 2, which you will add to this 7, and then calculate your value to be final like that in your answer. So that's how you calculate the trapping rainwater using this optimized solution. Now I'm gonna quickly show you the code dry run here, and then I'm gonna write that code in Leetcode so that you can understand and copy that code. Alright, so initially I want to calculate the size, which is going to be, I'm just gonna do it right here with this black pen. Alright, so my n value is going to be the height size because I have to calculate this. Now I'm gonna assign a left max array, which is basically going to be left max of n, and then create another array which will store all of the right endpoints, which is going to be right max of n. Now I already know the left max point and then the right max point of the array, which is basically going to be the starting point and then the ending point for left and right respectively. So because of that, I will simply store those values, which is going to be left max of 0 is going to be my height of 0, right? Height of 0, because those are the endpoints given, which is going to be height dot, oh sorry, it's going to be height of 0. Now it's going to be same value but from the last for the right max. Right max of n minus 1, which is basically this n value, is going to be height of n minus 1. Now you also want to initialize a variable which is an answer to be 0. Now you use one loop, which is basically for integer I equals 1. The reason we're starting from 1 is we're trying to repeatedly calculate the left maximum from this pointer, which will represent this value, and then go to this index and then represent that value in that order. So we'll start from 1 and we go till less than n, and then I plus plus, right? And then in each step we will basically calculate our left maximum value for each of these pointer, which is going to be the maximum of the current maximum that I have, which is going to be I minus 1, because I just stored that 0 left max of 0, which is height of 0 in my array. So I'm trying to see if that 4 is greater than the value that I am holding, which is height of I. If that's the case, then I'll store that in the left max of I. And then because of this for loop, in each index I have my left max calculated like that. Now I will use another loop, which is going to be for the right max for integer, and I'm gonna start this with in the last of the value, which is n minus 2. The reason I'm starting from here is basically I'm starting from here, from 2, because I already have the value 5 stored in my array, so I have to start from here. N gives you the current size, which is 6. If you decrease 6 with 1, it's gonna be 5, which points here, but if you decrease 2 from that value, it's gonna point here. Okay, and now I have to go I greater than equals 0, and then I'm gonna repeatedly decrease the value, and in here I am going to calculate the right maximum, which is going to be the maximum of the right max that I have, which is gonna represent I plus 1, because I have value stored like this, which is 5 here. Now if I want to calculate a value for this particular section, I have to go here and then check what's the maximum value, right? So that's why I'm doing I plus 1 comma what is height of I, and it will also calculate the right max and left max, same as this here. After that, we will use one loop to basically minimize the value at each index and then decrease its height. So that step I will directly show it in the Leetcode. Okay, just like we did here in our dry run, I'm gonna calculate my n, which is going to be height dot size, and then I'm gonna do left max n and then integer right max, and this is basically declaring two arrays in order to store left max and right max. And I'll also initialize both of the values, which is going to be left max of 0 is going to be height of 0. The reason I'm doing this is because I'm storing two endpoints in my left and right max value, because I already know those points, and then those I don't have to calculate any endpoints for those. For the right max, I am going to store the value, it's in the last pointer of my height, and then I will also initialize a value to store my answer, which is going to be 0. Now I'm gonna start a loop from I equals 1 till I less than n, I plus plus, and then I'm gonna calculate the maximum value for each of that index by using the max function given by C++, and then I will check if the left maximum that I have right now is greater than the height of I. If that's the case, I'll simply store that in the left max repeatedly. I'm gonna use the same for loop by modifying a bit, which starts from the second last value of my height, and then I'm gonna go I greater than equals 0, and then I have to repeatedly decrease it. Now I'm gonna calculate the right max by repeatedly comparing the value that I have at my last pointer, which is I plus 1, to height of I. So that will calculate both of the values. Now I will use another loop, which is going to be for integer I equals 1. I'm gonna start from I equals 1 to I less than n minus 1 and I plus plus. The reason we're excluding our first and then last value is because we don't need those, and then because those are the endpoints, so that doesn't represent anything. And basically we will be calculating our answer in here by minimizing the left max of I or right max of I, whichever is minimum. We will store that in our answer by decreasing the height of that particular value, right? After that I will be returning my answer, because because of this loop my answer will be calculated and stored in the answer here, and that will give me the final answer. I think everything looks good. Let's run this program, if it runs or not, and then if it successfully runs, we'll just submit the code. We got an error. It says int n is not assignable. What does this mean? Let's see. Left max got the error. Left max of I minus 1, and I got the error. I don't know why did I get the error. Left max of n, which is good. Right max is, and it should be good too. Oh, sorry, I had to do left max of I here because I'm using the index. I'm not using the variable to store the value repeatedly. My bad. I'm so sorry about that. I have forgot the index to store each value in particular index. This happens sometimes when we're coding. It's the general scenario that I get every time. So all of the test cases are submitted. So let's submit these if it submits or not. Alright, the code has been successfully submitted, but the catch with this problem is that we still can optimize this problem. How? Well, the reason that we can optimize this problem is because if you see it here, we're using two basically size, which is big O of n, space complexity, and we can completely eliminate this big O of n time complexity using another approach that we call two-pointer approach. I'm going to show you how we can code this particular problem and solve this particular problem easily using two-pointer approach. Now we can optimize the previous problem that we were doing, which was basically this trapping rainwater with the big O of n time complexity and big O of n space complexity. Now we can optimize that big O of n complexity using two-pointer approach. So let me write that down here. Two-pointer approach. So basically our array is like this. Alright, now we are going to use a two-pointer approach to solve the same particular problem, which is trapping rainwater. So the reason to use two-pointer approach is to optimize that space complexity that we were getting, which was big O of n. Basically we were using two left max and then the right max prefix values to calculate our final answer, right? But we can simply eliminate that by our left pointer and then the right pointer, and then we can simply calculate that here. Before talking about the intuition to solve this problem using the two-pointer approach, I'm gonna quickly show you the logic here. So the logic of two-pointer is pretty simple. You will assign a left pointer at the start of your array and then the right pointer at the end of your array, and then you will continuously check your values until this left pointer cross the right section or the right section crosses left section, which is basically left less than right. Now the idea is to calculate your left max. Basically you will assign your left max to be 0 and then right max to be 0 2, right? Now you will continuously use your loop, which is basically while left is less than right. While left is less than right, in each case you will calculate the left max and then the right max. Basically the left represents this pointer and then the right max represents that pointer. So you will first calculate your left max, which is basically going to be maximum of left max and then the value at height of low, and then you will also calculate the right max here, right max, which is going to be right max and then height of right. So in this left max, we are basically calculating the value from left side, and then the right max, we are calculating the value from the right side, and then we are trying to merge ourselves in between. That's how two pointer works. Now after we calculate that, we will check something here that will basically build up the intuition I'm trying to show to you. We will check if our left max, which is this particular value, is less than right max, we will do something here, right? If not the case, else we will do something here. Now what does this represents? What does this left max and then the right max means? Well, I want you all to think here. What is your left max value calculated right now? The left max is 4 and then the right max is 5. Now see this map. This is 4 and this is 5, right? Now if it rains, which wall is controlling the water? Which wall controls how much water can be trapped? You can easily see that this is the wall that is going to particularly trap the water. So basically, whichever is minimum wall, that will control the water that can be trapped inside that particular scenario, that particular heights. So that's why our answer, initially we will assign that to be 0. Our answer is going to be basically going to be left max, which is 4, and then we will decrease our height to, which is basically going to be height of low. If that is not the case, if our right max is less, we will store that answer, which is right max, and we will also decrease our height from the right side. I hope you are understanding this. If not, I will make it easier for you all. Let me zoom that out. So this is the code that I just wrote, and then I will pretty easily explain the code that I just wrote. So initially we'll point our pointers to low and then the right, and then we will compare if low is less than right. That's right, it's less, right? If that's the case, we will see our left max value, which is maximum of left max or height of L, which gives it 4, and then the right max gives it 5. Now we are basically checking which is our left max value that is less than the right max value, right? So 4, that we just got, is the minimum value, and if that's the case, then whichever is lesser value, that is controlling the height, or that is controlling how much water can we trap. That's how we are checking this. Whichever is less, we store that particular answer. To easily understand you all, I will show a diagram here. So let's assume this has a height of 4, right? And this is our height, and let's assume this has a height of 10. 4, 10, and it's here 0. It doesn't have any height. Now when it rains, let's say you have a left max of 4 and then the right max of 10, right? Now you compare, when you are trying to analyze the water, how much water can be trapped in this particular 0 height, the height that is in your left is particularly responsible for how much water can you trap.